All right, guys, let's go through these problems. Starting with numbers 1, 2, and 3, you are just combining like terms. So please do not touch the variables and exponents. So that's why number 1 is -2, a to the third b squared, just combining like terms. And we know that because we are simply adding and subtracting. We are simply adding and subtracting in between. So the powers do not change, the exponents do not change as a result. So right here my like terms are 5xy and 2xy. That's why my answer is 7xy minus 2x squared y. Subtracting -2w from -6w. So subtracting -2w. Subtracting -2w from -6w. That's where you're getting your -4w. Okay, so you have these answers. I'm just going through the explanation and the process. Hopefully we didn't have too hard of a time with 4 and 6. I'm going to jump into 5. You are squaring -x to the 5th or -1x to the 5th if you need to see that -1 there. So what's really going on is -1x to the 5th is multiplying to itself. Or you can think of that as -1 squared and x to the 10th. Final answer of 1x to the 10th or just positive x to the 10th. Zooming in here to 7. Again, we are just multiplying. So -5 times -3 is positive 15. And that's going to be x to the 7th power. You've got 3 x's multiplying here, 4 multiplying here. So altogether, because they're multiplying, you have 7 x's multiplying. Moving over to number 8, I have to take care of that square first, and that square goes to every component in that monomial, every factor. So we're squaring the -2. We're squaring the x squared, and we're squaring the y squared. So notice how when I squared the x squared, that became x to the 4th because it was x to the 2 times 2. So let's finish cleaning this up. That's 4x to the 4th y squared, and that's multiplying to -3xy to the 3rd. Line by line, 4 times -3 is 12. X to the 4th times x is x to the 5th, and y to the 2nd times y to the 3rd is y to the 5th, and that's not a 5, is y to the 5th. 2 plus 3 and 4 plus 1. Moving on to number 9. Just multiplication again, no exponents on the outside. So 2 times 5, that's 10. That's a to the -5, -5 plus 2. A to the -5 plus 2, so a to the -3, and b to the 8th. Remember that the product rule is a to the m times a to the n is a to the m plus n. That's when we add. When we're multiplying bases, we keep the base and add the exponents. So this answer is not wrong, it's just not simplified, and the reason why it's not simplified is because a is still being raised to the -3rd power. So final answer of 10b to the 8th over a to the 3rd, because a negative exponent is the same as the reciprocal of the positive. So if we reciprocate that negative exponent, it turns positive. Moving over to 10, I've already done something like 10, but let's do it again. This square does belong to the -4 and to the y to the 4th. So that's y to the 4 times 2, which makes 16y to the 8th power. Now for number 11, we do have to take care of these exponents before we can multiply. So let's take care of them. A to the 8th, b to the 4th, and c to the 12th. Remember the power rule. If you have a base number like a to the m and you're raising it to a power, these powers do end up multiplying. That's a to the m times n. All right, let's do that again here. That's b to the 6th and c to the 3rd. So this is the result of raising to the 4th power, and this is the result of raising to the 3rd power, and now we need to multiply these together, like bases with like bases. So a to the 8th, b to the 10th, because that's b to the 4 plus 6, and c to the 12 plus 3, which is c to the 15th power. For 13, we're going to go ahead and apply this -3 exponent first. So that's 4 to the -3rd, a to the -3rd, and that's multiplying to a to the -4th. I'm going to go ahead and multiply my a's. So that's 4 to the -3rd, a to the -3 plus -4. So a to the -7. Since both of these have negative exponents, we're going to rewrite them with positive exponents by reciprocating. As a result, I do have to put a 1 in my numerator. And last but not least, 4 to the 3rd is 4 times 4 times 4, which is 64. Final answer. I've already done a problem very similar to 14, so I'm going to go ahead and skip that one, and hopefully using number 11 will help you with number 14. Don't forget that the exponent does apply to the 3 and to the -4, as we've done multiple times. Now taking a look at 15, this exponent of 3 does apply to everyone in the parentheses, so 4 to the 3rd, a to the -3rd, b to the 15th, and c to the -9. Okay, 4 to the 3rd has a positive exponent, a to the -3rd and c to the -9 both have negative exponents. So we're going to reciprocate those to make them positive, leaving us 4 to the 3rd and b to the 15th in the numerator, a to the 3rd and c to the 19 in the denominator. Oh, we could rewrite 4 to the 3rd to be 64. 4 times 4 times 4 is 64. For 16, you are just reducing, so 9 and 3 will reduce by 3, making that turn into 1 and this turn into 3. And d to the 8th and d to the 10 will reduce by d to the 8th, so 8 d's cancel, leaving me with 2 d's multiplying in my denominator. So I'm left with 3 over d squared. Again, 8 d's completely canceled. There's 8 d's multiplying up here, 10 d's multiplying down here, and if you start canceling off, you're going to be left with 2 in the denominator. Bringing me over to 17 for the same type of problem. We can reduce here by 2. And then my a's, this a will cancel completely, leaving me with 4 a's in my numerator. And for my b's, these b's will cancel completely, the b squares, leaving me with 1 b in my denominator. So I have 3 a to the 4th in my numerator and 2 b to the 1st in my denominator. Number 18, just like 17 and 16, let's start canceling away. So -8 cancels completely to be a -1, and this becomes a 4 on the 32. You cancel completely an x, leaving this one with 2 left over. You cancel completely a y, leaving this one with 1 left over. And you cancel completely a z squared, leaving this one with 3 left over. Now 4 over -1, like everything's canceled from the bottom. And 4 over -1 is simply -4, so a final answer of -4 x squared y z to the 3rd, and everything from the bottom is now gone. All right, so for number 19, I do need to raise the 4th power first in my numerator, so I'm going to end up with 2 to the 4th and y to the 20th, and that's over 10 y to the 15th. I'm going to go ahead and do 2 times 2 times 2 times 2, so 2 to the 4th power. 2 to the 4th power is actually 16, so that was 2 to the 4th y to the 20th. Just rewrote 2 to the 4th as 16, so now I can reduce by 2, so that makes 5, and that makes 8. And I can cancel 15 y's from the bottom, making this turn into 5 y's multiplying for a final answer of 8 y to the 5th over 5. Now 20 probably was a little tricky, but I do want to remind you that we do have to take care of this exponent first, and that exponent belongs to everyone inside the parentheses. So everyone's going to get hit by that exponent of 4. So let's do that. That's 3 to the 4th, x to the 20th, y to the 12th, over x to the 12th and y to the 24th. So again, what we were doing is I was hitting each component inside this parentheses with that exponent. 3 to the 4th, x to the 5 times 4, y to the 3 times 4, and so on and so forth. So everybody got hit by that exponent of 4. Now we can cancel. 12x's cancel in the denominator, leaving me with 8 in the numerator. 12y's cancel in the numerator, leaving me with 12 in the denominator. You've got 12 on the top and 24 on the bottom. So final answer, 3 to the 4th is 81. 3 times 3 times 3 times 3, x to the 8th, over, looks like we just have y to the 12th on the bottom. And last but not least, number 21, which has quite a few steps. First thing we want to do for 21 is square that monomial on the top. So we've got -6 squared, a to the 10th, b to the 2nd, and that's over 12, a to the 7th b, subtracting with 8, a to the 3rd b. First thing I'm going to do is I'm going to go ahead and rewrite -6 squared. -6 squared is equal to 36. And I can reduce this fraction. So 12 turns into 1 and 36 turns into 3. Reduce there by 12. A to the 7th is gone, leaving me with a to the 3rd. And b is gone, leaving me with b to the 1st on the top. So 3, a to the 3rd, b to the 1st, minus 8, a to the 3rd, b. And now we are just combining like terms. Keep in mind that you are not changing the variables and exponents. They are like terms. So 3 minus 8 is -5, a to the 3rd, b. Final answer. If you still have any questions on any of these problems, please do not hesitate to email me specifically about a problem. That helps me target what you need help with. So thanks for watching, and I hope that this helps.